if you look up shape from shading, you'll see a lot of pictures that look like this. And these are typically synthetic results. So given some depth map, you can make some sort of a shaded image, and then you can show that you can recover the shape that's really there. Unfortunately, one of the reasons they show synthetic results so much is that the results on real images are somewhat, shall we say, less than wonderful. In fact, there was a paper by Mubarak Shah and some students, I think in the late 90s, early 2000s, where I think the phrase was something like, well, it works poorly in the lab and not quite as well as that in real life. You know, basically, and why is that? Well, the problem is these assumptions are overly restrictive. I mean, a constant albedo everywhere, that means you get no variation in the color or the underlying texture of what's there. You know, knowing about the light source, the orientation directions, it's a very brittle type of computation. So what can we do instead? Well, what we can do instead is we can take more images, all right? And this is what's referred to as photometric stereo. So the idea is that we take picture from the same camera location. So we can still have Z as a function of X, Y, same object, but with different lighting. So here we have the picture taken from the same location with different lighting directions. And what we want to get out is this, right? The Z is a function of X, Y. And unlike traditional shape from shading, with enough lights and sort of careful calibration, etc., we can also recover the albedo, the reflectance function at every point. So now we don't have to make this overly restrictive assumption that the color or the reflectance of the object is the same everywhere. We're allowed to let it vary.